In this podcast, we're looking at single displacement reactions, and we're specifically going to look at how we figure out whether or not a single displacement reaction will occur based on the elements involved in the compounds. So just a reminder that is in a single displacement reaction, you have one element replacing a similar element in a compound. So this means that a metal will replace a metal, and a non-metal will replace a non-metal. Single displacement reactions usually involve ionic compounds, and so it's easy to figure out which element in the compound will be displaced, because a cation can only replace a cation and an anion can only replace an anion. So we've learned from our experimenting in class that not all metals will replace all other metals in a single displacement reaction. In fact, it depends on the relative reactivities of the two elements. So whether or not a single displacement reaction will occur depends on the relative reactivities of the elements involved. So it means that when you compare the two elements involved in the single displacement, which one is more reactive? So scientists have done a whole bunch of different experiments with different metals, and from these experiments, just like the ones we've done in class, they've been able to list elements in order of their reactivity. So this ordered list is called the activity series, and we use this activity series to predict whether a single displacement reaction will occur. If you open your textbook and take a look on page 126, you can see there's an activity series that looks like this. This is a list of metals with the most reactive metals up here in the top and the least reactive metals down here on the bottom. The activity series predicts whether single displacement reactions occur because elements will only replace elements that are less reactive than themselves, which means they will only displace an element lower than it on the activity series. So the reason why our method of polishing the silver bracelet worked is because aluminum is much higher on the activity series than silver. The aluminum dip also polished the copper penny because it is above copper on the activity series. Aluminum, however, would not remove an oxide from magnesium because it is lower than magnesium on the activity series. Okay, so make sure you have this stuff copied down. You're not expected to have this activity series memorized. In fact, it's written on your periodic table for your use. You just have to know how to use it. Okay, so get this copy down. We'll do a couple examples. All right, so in these examples, we want to use the activity series to predict the products. In our first reaction, we have aluminum and iron 3 oxide. So we want to know whether or not a single displacement reaction is going to occur. So we need to look at our activity series here. Aluminum is right here on the activity series, and iron is below it on the activity series. Knowing that elements only replace elements that are lower on the activity series than themselves, we know that, in fact, aluminum is going to displace iron from the oxide, giving us our products of iron and aluminum oxide. In our next example, we have zinc and we have magnesium nitrate, and we want to know what our products are if we get a single displacement reaction. So we need to look at our activity series again, looking over here. We see that we have zinc here and we have magnesium above it on the activity series. So because magnesium is above zinc on the activity series, zinc will not replace magnesium in a single displacement reaction. So that means we basically just get no reaction. And that's what we write for the products, no reaction. So metals are not the only types of elements that can be displaced in a single displacement reaction. Halogens also have a separate activity series, and it's found on page 127 in your textbook, and it looks something like this. It acts by the same rules as the activity series for metals. Elements will only replace halogens that appear below them on the activity series. So fluorine up here in the top is going to replace chlorine, bromine, and iodine, but fluorine will never be replaced by anything else because it's the most reactive and at the top of the activity series. So if you come across a single displacement reaction involving halogens, it uses the same rules that you've just learned using the activity series for metals. So that ends this podcast on single displacement reactions and figuring out whether or not they're going to occur using the activity series. And remember that activity series is just an order of elements based on their reactivity. So you are going to be required, or you are expected to be able to use an activity series to predict the products of single displacement reactions. And I'm going to provide you some practice to refine that skill in class.